Hey guys, this is our presentation on AP Minecraft in Physics by Landon
and Dustin.
So get ready, buckle your seatbelts, get your popcorn. So you're probably wondering, how does physics actually relate to Minecraft? In our presentation, we're going to be covering conservation of energy, angular momentum, projectile motion, friction, momentum, and finally, open and closed circuits. Okay, so the conservation of energy in Minecraft starts with the equation mgh plus 1/2 mv squared equals the constant. And this relates to Minecraft as at the top of the roller coaster, the minecart will have more gravitational potential energy because of its height. And as it moves downward, that stored energy is converted into kinetic energy, causing the cart to speed up. So our next point is angular momentum. And angular momentum is described as L equals IW. And instead of actually playing golf, Dustin and I are actually too lazy, so we did not go outside and play golf. And unfortunately, golf is not in Minecraft, so we couldn't use Minecraft as an example here, I guess. Instead, we have Kai Trump playing golf. So at the start of a swing, a golfer, Kai Trump, has her arms more extended away from her body, increasing the moment of inertia and making the rotation slower. But as her downswing begins, her arms actually move closer to her body, decreasing the moment of inertia. And since the angular momentum stays constant unless an external torque acts, the angular velocity increases, which is why the club speeds up before hitting the ball. But within this, torque is also applied, which is her twisting force of her body by her hips and muscles and shoulders, and it acts to change the angular momentum during different parts of her swing. Overall, the golf swing works because Kai Trump carefully controls and rotates her body, and it creates torque to start the motion and then changes toward different parts of her body to adjust her moment of inertia, which increases her club speed, and it results in faster, more efficient rotational energy into the ball impact.
As the villager's minecart travels along, it collides with the stationary minecart on the rails. After the collision, the villager's minecart comes to a complete stop. This means that the collision between the two minecarts is an elastic collision because all of the cart's momentum was transferred to the other cart. The first equation above shows the total momentum being conserved, written as ma times va plus mb times vb equals ma times v final a plus mb times v final b, which proves that the total momentum before equals the total momentum after. And the second equation shows the total kinetic energy being conserved, written as 1/2 ma times va squared plus 1/2 mb times vb squared equals 1/2 ma times va squared final plus 1/2 mb times vb squared final, which again proves how the total kinetic energy before equals the total kinetic energy after the collision. Alright, our next topic is friction, and we are demonstrating this in Minecraft by walking on ice versus walking on honey. As you can see, the ice block has less friction than the honey block because it took more time to travel the same distance. The equation for friction is equal to the coefficient of friction, which is how much force is acting between two surfaces. A higher coefficient of friction means that it's harder for the block to slide, times the normal force, which is the natural force that opposes gravity and keeps the blocks from falling through the earth. Knowing this, we can safely say that the coefficient of friction for the honey block is greater than that of the ice block because the normal force stays the same. Our next topic is open and closed circuits. When you flick the lever, it sends an electric current and activates the dispenser, which shoots out the arrow. An open circuit is when the lever is in the off position and the redstone is not activated. And a closed circuit is when the lever is in the on position and the redstone is activated, sending electricity to the dispenser, which shoots out the arrow.
So, when a dispenser shoots an arrow to the left, the arrow follows a path that's projectile motion. And it means that the arrow is being pulled down by a constant gravity velocity. And using the equations on the screen, we can say that velocity stays constant. So we use that equation, x equals x0 minus v sub 0 t. And the negative sign shows that the arrow is moving to the left in the negative x direction. And for the vertical motion, the gravity causes the arrow to accelerate downward, and that's shown in the equation y equals y sub 0 minus 1/2 gt squared. And right now the arrow is in the air and it falls faster downward because of the gravity keeps increasing its downward velocity. And combining these equations, we get a curved path as well. And this explains why the arrow doesn't travel in a straight line, but instead travels downward as it moves toward the left.